Hello everyone, I am Prasanna. Welcome to the session on classifying the text based on a model. It can be a multinomial model, it can be a logistic regression model or support vector machine. So let us consider a problem statement, for example, car reviews. So the car reviews can be positive or it can be negative. So let's first take the test case used here. So as you can see in this Excel sheet, you have the test data set, input data set, such as to say for this machine learning process. So you have a review date, author name, vehicle title, review title, and actual review. Say it's been a great delivery vehicle for my cafe business, good power, economy, match easily, taken care. I haven't repaired anything or replaced anything. So you can see this review seems to be good and they have got a rating of 4.6, yeah, out of 5. So you have some less rating as well, say 2.1, which is not good. He was disappointed with the car and yeah, so this is the buyer of the car, say author. So date, yeah. So you can see this is the test case. We have some say 8,500 entries, car reviews, and um, we have to now train the model and classify them and predict the review if it is positive or negative. Yeah. This is going to be the problem statement. We have to find out if the car review is positive or negative. Yeah. How do we do that? Let's go step by step. So what are the steps involved in solving this problem? So first we have to do the data cleaning. So we have to see if the car review entry is in particular order which we want. Does it have all the data? Does it have any other unnecessary data, etc.? We have to check that. And then we have to split them into training and test data. So we have to train the model with the training data and then have also some data for the testing to predict how good the model is. And then so as we do that, we have to first get the data and transform. We have to each review is a word, so we have to transform into numeric form. So first we have to fit them and transform them into a matrix which represents the review actually. So that we will see in detail in the example. And then you have to fit the model. Once we have the input data in the matrix form, we have to fit the model with this transform data and then predict, test the model. I mean, now we have to see how good the model is with the fitted data. So we have to transform the test data and predict if the test output and the predicted output of the model are quite similar. So in this session, we will be addressing how the features list look like, how the transform matrix look like, what does each car review, how it is represented in numerical form, how the feature count is calculated, so etc. So there will be several questions which we will address in this session. So now let's jump into the Python code, which will help us in understanding the problem better. So now the required libraries, as you can see, pandas, OS is actually to have the directory addressed actively and then numpy and the regular expressions for filtering it or anything. Yes. So now important thing is that this is the skill and module which is used in the Python to do this. Actually, it has several modules, yeah. And then you have the input data Excel sheet which we saw now. This one is being fed here, as you can see. And then you have the um, review file which is here addressed, and then you have something like bad lines. So if the data has some unnecessary lines, or if it is not perfect for the perfectly following the order, then you can skip those. And you can also drop which the values are empty, and then some string operations which is based on the input data. So I have commented it out. This can be scenario like you have to convert it into a numeric form. The rating will be always be 1 2 3 if it is in string. If it has something, you have to convert it, and then if it has some additional special characters at the end, you have to replace them, etc. So now you have to convert them into numeric if the rating is not in string form. Yeah, and then you have to you can also ignore the neutral ratings. Say it is 1, 2, 3, 4, 5 are the ratings, and if it is 3, it is going to be neutral, neither good nor bad. So therefore you have to remove them. So you have to use this. So this is the data frames used in the Python. So you have data frames, as we have seen in another video. It's nothing but a table of rows and columns. So you have the rows reviews, columns is nothing but the review rating, etc. So what we are doing is we are adding an additional column here, positively rated. So, and now if the rating is more than 3, it would be 1, and if the rating is less than 3, it would be 0. That is the condition. So we have added a new column representing the rating in numerical form, representing the review in numerical form. So instead of having 1, 2, 3, 4, 5 ratings, we'll have 1 and 0. 1 means it's positive, 0 means it's negative, either 1 or 2 rating would be negatively rated. So now let's take the first 100 rows and print them and see how it looks like. So of course it goes further. So you can see the first 100 rows, you have review date, rating, positively rated. So this is more than 3, 1. If this is less than 3, it is 0. It is 5, it is 1. So that's how it is now transformed. Now. It's now a new column is added to understand the review better and to simplify the problem statement. So now we have the data cleaning done, and now we need to go to the next step, which is explained here. That is splitting the data into training and test data. How do we do that? So we have a module, we have the imported the model selection, and we have to use the train test split method. So this would method will hold a first column as the review, actual review from the customer, and then the positively rated, either 1 or 0. 1 means positively rated, 0 means not positively rated. So we have two columns, and you have to split them now into training and test data. So you have on the x-axis the reviews, and the y-axis represents the ratings, positively rated 1 or 0. So you have now split them into training and test data. So these each and every variable here, x train, x test, y train, y test, are representing the series in pandas. So it's like a column in the table. We have seen data frame containing the whole set of data. Now we are split into the series. So now let's see what the series of panda series this contains. So X train, what does it contain? X test, what does it contain? Y train, what does it contain? How does the shape look like? Now let's see that now in this example. So I'm printing out all these with the help of this its index. So I log of 0, etc. So now it should have printed out. Let's see its data, how it looks. You can see I'll maximize it. So you can see this is the X-train first data. This is the first training data used. That is the review. You can say he is mentioning it. I feel that 20,000 is I stole this thing. One of the best thing is it's still under warranty with it. These are the only way to travel if you're buying for every day. It's probably not the right vehicle. So you can see very easy to drive despite its size. Rides nice and quite inside. So it looks to be somewhat positive. Bulletproof, etc. So you can see the test training data. This is the review, and how is it the output is? It's positively rated, of course. So it's 1. And then you have the test data. For example, one of the best cars I have owned, the speed. This is for just checking the model. So this is also a positive rating, and it has given 1. So now we had 100 inputs given and we have not split them. How it is split? You can see the shape of the training data is 75. So which means out of 100 rows of customer reviews, 75 are used for training and 25 used for testing purpose. We have splitted them in this ratios. 75 is to 25 out of this 100. So now you can see the shape of the testing as well, as we can see. So the X and Y column has to have the same shape. Yeah, that is similar. So X, Y here for the training, and X test here and Y test here for the testing. So now we have now split the data. Now what we have to do next is let's go to the PDF and see what we have to do next. You have to now fit and transform the training data into CountVectorizer. You have to now fit them and transform those training data. How do we do that? Let's see now the example. So now we need to import a CountVectorizer class for this. So it's available under feature extraction text, import CountVectorizers. So we are creating the calling this one, and then using the method. This is the class, CountVectorizer class, and we are calling the fit method, and we are inputting the extrain data. That is the customer reviews for the training, and it gives out the CountVectorizer class with the extrain data. Now let's see what its type is and what does it contain, what does it contain, the features, and yeah. So let's see its shape, etc. Yeah. So now let's go to the output. We have run it already. So you can see that it is of type CountVectorizer class. You can see the vectorizer, what the data that we have fit, and the examples. Say for example, afraid. So it's one of the word in the this thing. So you have several features here. Now let me output all the features, not only the 120th one. So I'm going to output all the features. You can see here it has so many features that we cannot print it, of course. So it has these many features. So maybe in you have dots in between, that's why. So maybe let's try this one. You can see here. So the car reviews that we wrote saw is actually split it into words. each word. So bad, badge, avalanche, average, building, chairs, comfortably, concept, curious. These are all the features available in the reviews. So each word that you see in this Excel sheet is actually a feature now. That is done by this CountVectorizer class. So now let's go to the application and say let's just print as we had before, one example of such a this thing. And now let's see the shape. It's actually a list as we saw. So therefore it's just a list here. It's just a list here. And we are converting, we are getting the ND array get features out, and that's the array list. You can see it's array, n dimensional array. It's of type n dimensional array having this much of feature count. So this is the length, such as to say. And its shape, yeah, of course its shape, and it's now we are converting into a list. So it was actually a n dimensional array initially, this features output, which is in this shape, say 1467 features. So n dimensional array. So now we can convert this easily into it's actually having one dimension data. So we can convert this into a list and type them as a list, and you can see it is typed, and it is now is type of class list, and it has the length of the same count what we saw. So from n dimensional array we are converted into a list, and just we are showing it in a simplified format. Now you can try out yourself, say for example printing the index of the word car in the list. So feature as a list with all the words available in the Excel sheet, reviews, exactly, customer reviews, and then you can find out each of the words index. So for example, car index, what it is, etc. So let's see what's the index of the car here. Let me run it. You can see 247. So 247 is the index of the car. So now if I print this 247 in the list, it will give out. I'm just helping you to interpret what the output of the features from the CountVectorizer is, in case if you're lost. So you can see here now it's breaks. Of course, we have to. Yeah, it keeps changing. So the index now we set to 65, but if I input 265, it's giving out another this thing. So what we can do is we can try to put this in a variable and print them out in the list. So it's just cross verifying both. It has to match. Now this is the index. uh, So now let's try this. So I have saved that index into a variable. You can see here the index is 264. I'm printing the output from the feature list. So it keeps changing. It's taken in the random order. So therefore 264 and um, say it's the index of the car used. So now let's now see the length as we see as we seen it already. The length is 1483. Now what we would do is as we go further, we have now fitted that training data into the CountVectorizer, not to the model yet. And now what we will do is we will now transform them. So you can see here in this line. So we are transforming the data, extrain data, into a matrix. And let's see the shape of it. Print shape of the transformed matrix. What type it is, and we are converting them into array, etc. So now let me run this. Yeah, it's case sensitive, as you know, Python. Print has to be. So now you can see here the shape of the transform matrix in this form 751497. So you may be wondering what is this number is. Here is very important to understand. So we saw the count of we had totally 100 rows, right? 100 rows from the Excel sheet taken. 100 rows. You can see here 100 rows of data. And then you have split it into 75 training data and 25 test data that you remember. And now going further, what we did is we fitted the data in the CountVectorizer, and then we checked out the entries of etc. So we saw after fitting the feature count is 147. So now let's see how many rows of training data are there. 75 rows, yeah, out of that 100, and each row will have features, right? Or nothing but the reviews. So we saw the length of the features, that is the customer car reviews words actually set into a feature list, and the length would be 1497. So you can say 75 rows and then 1497 columns in that form. Let's take for example, each row will have 1497 columns of data, and each column represents the features. Does it represent the word? No. It represents the count of the words. Yeah. Now let me simplify it with the picture. So you say car review, that what you have taken from the Excel sheet, for example, has say this many of data. So car review one, say bought the car, they are overpriced this car, very good. So you can see now, let's now do the same thing here manually. So what is the feature count here? Total number of words 1, 2, 3, 4, 5, 6, 7, 8, 9. Because car is repeated twice, so unique is 9. So now let's take a matrix form, and we say the car row review 1 is the first row in the matrix, and you see bought is appearing once, the is appearing once, car is appearing twice, and then day is appearing once, over appearing once, price appearing once, this appearing once, very appearing once, good appearing once, so etc. So you can see this is the 3, 6, 9. You can see the count is 9 because the unique number of words features is 9. Okay. Now this is the first row we have set. Now let's take the car review too. The car is very good. Car is very good. So then you have the bot is not appearing in this car review, so 0. And then you have the is appearing once. Yeah, right. Car is appearing once. So it's in the first row it's appearing twice, but in the second review it is appearing only once, so 1. And then remaining all 0 except very and good. So this is how it is transformed into a matrix. So the matrix will hold the feature count of each car review. So this is how the transformed data is, and it can be used further in the multinomial regression model. So we have to transform them. So the words are actually represented now in numbers, but the fitting happening in the model is actually transformed into numeric form. It's a high dimensional data. Of course, you cannot see that, represent them that, but you can see here simply each row here represents its count of the features. So now let's see that in the code. You've seen that in the code, the transform matrix will hold like this. And now for easy understanding, let's try for better understanding how it is shown in the code. Yeah. So what I would do is now I would print. We are doing some operations here. Let's say the shape of the transform matrix we saw, and then let's see the type. You're converting into an array this matrix, so it will be a two-dimensional array. Let's see how its shape is looks like, what its type is, and let's print out this one. So you can see here uh, 267 is the index of the car percent. So you can see now we have transformed. This is the matrix in this form, 75 rows of training data and feature count 1470, and we have transformed them. This input is a matrix form. You can see a matrix class, and we are transformed into n-dimensional array. That is two-dimensional array, and it is shaped, of course, look like the same. And now what we have printed out is 0. Because it does not appear, I guess, the car in the first review as we see. Yeah, let's run it again. Yeah, now we have got a big review. So this car is unbelievable. The first review in this training data now. This car is unbelievable. It has room for the family and to haul different odds and ends. Even with 425 horses, I have been getting around with an occasion jump. But don't let me, if you don't keep your foot. contrast and the mileage will drop. This car, you can see again, the car is repeated twice. So this feature is repeated twice. So we will see first its index. As you see here, 277 is the index, and then its word car, and we are outputting how many times it's there count. You can see it's 2 times. Yeah. So just to be sure that we are getting the right data, so for better understanding in the input, let's do it this way. You can see here now, finding the index of the feature present in the list. That is the finding the index of the word car in the feature list. So we have 271. Yeah, correctly outputted. And let's see the other way around. What is the index 271 from the feature list with the word car? You can say it presents the car. So it's correct. Now, number of times this car word is feature is appearing in the first row of training data. It's now appearing only once. Yeah, let's check that out. Yeah, you can see here as well. So let me close it and rerun it now. So you can see once, only once. Yeah, only once. But in the test data, of course, multiple times, but we are not concerned. So let's try one more time. If we again get the count 2, yeah, once again one time. Let's rerun it here itself. Yeah, now we have it 3 times. So let's see now in this first training data, how many times car is appearing. Yeah, again to the top. Let me take this output together. So it has to appear at 3 times. Let's see. 1, 2, 3. So this is one time, second time, third time. 3 times it's appearing in the first review. So we have confirmed that, and it is printed out here. So in the matrix, first row, the index 4, first in the first row, index 264 will have 3, as we just saw in the PDFs in simplified format, how this is transformed now. So now we are clear about the transformed matrix. So we now have hopefully we are now clear with the transformed training data. Now we have to fit them into the model. It can be a logistic regression model, multinomial model, or it can be a support vector machine. Yeah. So now where do we do that? We are doing that in this step here, fitting the model with the transformed matrix and its output. So this is the X training data, transformed matrix data, and this is the Y train data. It is either 1 or 0, as you remember. So now the model is obtained from this naive Bayes, or it can be a linear model logistic regression. Now we have taken the instance of the logistic regression model and fitting them with the training data, that is the transformed matrix and the output now. So now we have fit the model, and the model is now ready. Now we have to predict. So what we are going to do is we are predicting with the help of the method predict available in the model, which will hold two inputs, which will hold, yeah, it should have to input the transformed test data. So we are using the same vectorizer instance that we used to fit the X training data, but now we are transforming it instead of the training data, or we are transforming some input text. So the first text would be like, it's been a great delivery vehicle for my cafe, economy matching easily, it looks to be positive, haven't repaired anything or replaced anything. And let's see the one bad comment, some very early body rust on proof, poor visibility, bad condition, bad tires, bad price, not recommended, costly, etc. So it looks to be a bad review, right? So we are now predicting these two inputs, one with the positive and another one with the negative, with the help of the model instance that we have, with the help of the predict method of the model class. So now let's see, we have not used the test data to test it, we are just simply testing it with the examples. So you can see here, it has predicted. So the first one was very good and the second one was very bad, disappointment. So it has now predicted this correctly. So with the help of just 100 rows of training data, but again it depends how good the model is, how good the model is trained with the training data, and how the output is. So now let's now test the model with the help of the test data that we have. So now we have to transform the testing data, similar how we did the training data, but here the vector instance, the vector CountVectorizer instance is used same. It is not instantiated once again and fitted with X test data. It is directly used, and but here the transformation is only with respect to the testing data. So to clarify it better with a picture, so we have initially got that CountVectorizer instance using by fitting the training data created through the X-train, and we are using that instance itself for transforming test data. So we already transformed training data, which we saw before fitting the model, but now we are transforming the test data but using the same instance. So conclusion is the own data used for transforming the test data is created by fitting the X-train data, which we already did in the beginning. It is not recreated once by fitting the X-test data. Yeah, that's a point which we may ignore. So we are now clear. It's again at matrix holding the test data. So we have, if you remember, 100 rows of input are there and 75 training and 25 test data. So the test data will now have 25 rows of data, and columns would be number of features, which will be the same. So it's now transformed now. Now we are going to predict with the transformed data. So if to be more clear, let's test. Let's check the type of X test transform before we are testing how good the model is. and the shape of X test transform, of course, if it is having a shape, of course. As I mentioned, it should be a matrix with 25 rows, and the columns would be equal to the so yeah, as you mentioned, 25 rows of testing data from the 100 rows, and the feature count remains the same. And it is now it's in the form of a matrix, and its shape is this one. We confirmed that, and we are converting once again into an array and doing etc. to check it. Yeah. So now um, we have the transform test data and we have the model ready. What next? Just predict how good the model is. Yeah. The next step. So last step, such as to say, and let's see how good the model is now. So now predict, the model has the method predict probability. So we had a method predict which predicts just the class labels or the type. So it's positively rated 1, negatively rated 0. So it's just defining the test. I mean, it is just giving out the directly the type of output actually. But it's now it's now predict probability will give out the class probabilities. So explanation here contains negative class and positive class, both it contains the output. Yeah, let's see that, of course. So we are now predicting the model probabilities. It will be, as you know, the probability value would be in the range of 0 to 1, and we are inputting the test data transform test data matrix, which we saw, which will be 25 rows and n number of features. And now we are taking just the second column. Why? Because the output is measured only in terms of the positive class. So let's see now first the output. So what I would do is I will simply output them for a better understanding. Let's see what this output gives. Just inputting this transform data, test data, and predicting the probabilities. So I'm running the model. As you can see, it's again two dimensions are there. So the first row column represents the negative class, that is rated negatively 0. There is no positive ratings here. And the second column represents the positively rated class 1, class label 1. So this is how it is classified. So we have to measure its performance of the model, how good the model is based on only its positive class 1. So let's predict the probabilities with respect to this one. We have predicted it and transforming into a model, and let's see its type, shape, and of course that's more clear. It would be it will be an array 25 rows, of course. Now we have predicted the probability, so it will have some 25 rows of output, 25 rows of output that we have it. So this is the one, 9.9.9.8 something. This is the probability value output. But now we have to compare it against the test data that we have already have it ready on our plate. So in the beginning we had splitted from 100 rows into 25 rows of test data. That will also include the output of those test data, which we have it already. So we are now comparing it these two both. So how the comparison is done? You can first, let's say, now let me not output everything. Let me output the predicted probabilities. So I would predict, once again, I'm repeating it. Now we are outputting just the positive class, that is class 1, positively rated as 1. It's not 0. And it's not the actual value, it's the probabilities. Now we have tried to put the test data. Now this is not probability. Remember, this is just the value directly. I mean the class label itself, not the probability. Let's see how the output looks like. You can see here the probabilities of those of the outcome from the model for the test data, test input data, and actual test data output. So this would be actually the class label. It's not the probability. So you can see these are all the positive rated, negatively rated, etc. Now, but these are the probabilities. Now, what we are going to do is, it's because we have to, you have to now see how good the model is. So we have to compare them, the output that the model has given and the output that we already have on the plate. So for that, we are taking the test data, plain class label 1 or 0, positively rated or not, and then the probabilities of the model. So it's a value and it's a probability, remember. And there is a method called ROC score class. There is a class ROC curve or ROC score from the metrics. So this will give you the value, how good it is. So we saw that now it's around 4.43 that we saw in the output. AOC score is 0.43. It's called as area under the curve, or area under the curve. So how much area is under this curve that we see here? Yeah. So this curve is ROC, receiver operating characteristics, etc. So now let's dive deep into the basics or basic understanding of what ROC curve is and how we are predicting it, etc. Some theory behind it shortly. So just to rewind once again, predict probability will give two classes, class 0, class 1. Class 1 is used for plotting the curve. It contains the probability, not the class values. So the predict method from the model contains the class values itself, but the predict probability are the probabilities. So now area under the curve, ROC curve, etc. Now let's discuss it. So ROC stands for receiver operating characteristics curve. It's a curve needed to avoid the confusion matrix. What a confusion matrix is, yeah, let's see now. So to keep it short, what we are doing is, this is the model, logistic regression model. Yeah, this is a logistic regression model that we have. So you have the probabilities here, positive related car reviews. So you have different thresholds, say 0.1, 0.25, 0.5, 0.9, etc. So thresholds for the probability. Just simply consider that the threshold of 0.1, we have some number of positives. Positives, I mean true positives. That is, say for example, we have now totally 4, 5, 6, 7, 8, 9 data points. Okay, the one with the circles, okay, the one with the circles represent bad reviews, that is positively rated will be 0. The one without the circles are positively rated 1. So when the threshold, when the probability is 0.5, then we can say that there are 3 positives. Above is positive, of course, above is positive as you saw, no? 3 positives, true positives, 1 false, I mean, true positives, 1 false positive, because this is going to be, this is actually a negatively rated one. So it should be below this one, but it's above this one, the circled one. So I'm repeating once again, the without the circles represents a positive, with the circle represents a negative, and when we have considered threshold of 0.5, we have 3 ratings above this positive, true positives, and one which is not actually a positive, it is one false positive. Similarly, true negatives. So you have 3 true negatives, circled one, and 1 false negative. So when we consider the threshold of zero point 0.5, the formula is true positive rate is equal to true positives. In this table you see actual value, predicted value from the model. The actual value would be good, bad, predicted value bad, good, good, bad. So if you see TP stands for true positives, both are good, and uh, TN stands for true negatives, both are bad, and it is actually bad, but it is predicted as good, so it's falsely predicted. It's actually good, but it is predicted as bad, so false negative. So this is called as confusion matrix. So when we plot it, TPR is true positive rate given by the formula TP divided by TP plus TFN. That's true positive divided by true positive plus false negatives. So for this condition, you will have true positives of 3, and the probability of 0.5 is 3, and true positive is 3 plus false negative as 1. So what is false negative here? This one. So we have 0.75. False positive rate is false positive divided by false positive plus true negative. So that would be, for what is false positive here? This is false positive 1 divided by 1 plus true negatives, how many? 3 for the threshold of 0.5. So it's 1 by 4 is 0.25. So we have got some true positive rates and false positive rates for the threshold of zero point 0.5. So for each of the threshold values, we'll have a different true positive rate, false positive rate represented in this confusion matrix. And with this, we cannot actually come to a conclusion between the actual and predicted values from the model are good or not. So we have to have a curve. That's why this curve is coming in place. You can see it's plotted. So against true positive rate against false positive rate. So you can see this curve is getting these values. When the threshold is, say, for example, 0.5, then true positive rate is 0.75 and false positive rate is this point. And similarly, when the threshold is 1, when the threshold is 0, 2.5, for different threshold values, we will have different true positive rate and false positive rates, which will be plotted like this. And this curve, which we get from the true positive rate and false positive rate axis, is called the receiver operating characteristics curve, ROC. And the area under this curve is represented as AUC, which represents the value which is less than 1, and the more the area is, the better the predictions are, better the model is. So, so I've shortly explained how this actual logistic regression curve model is transformed into ROC curve, and what is AUC, area under this ROC curve. and what are the formulas involved, true positive rate and false positive rate shortly. So now let's jump. We have understood now what ROC, AUC. So AUC represents the score, how good the model is, and it is taking the maximum value of 1. So let's now see in our example how it is, how the output is. So we have seen the AUC score as 0.5 and the curve looks like this. Now what I would do is, it's not smooth curve, right? It's not at all smooth because the data is minimum. The input data that we have used for this operation is minimum. So we need to have more data. Let's say if I take some 5000 instead of 100, you can see that curve is smooth. So this is the area under the curve, and you can see more score because we have huge amount of data to train the model, and of course the output predictions will be very appropriate. So when we have less data, we will have very less AG score. When you have more data to train and test them accordingly, then we will have a better AUC score, area under the score. So shortly, let me show you the different methods used. False AUC, ROC AUC score and available under the metrics module. And we are inputting the test data, not the probabilities, and then the predicted probabilities of the model. And outputting that output, and then let's see the FPR, TPR thresholds, etc. So for better understanding, um, let me show you the different values used here, which will be outputted. And of course, if it is huge, then it will be running into a memory problem. So let me reduce them. And after reduction, and see, of course, it's not that good as we compared to the last one, but it is somewhat okay. So you can see here, the AUC score is 0.8. So you can see now, let me close it, and it's too much. Let's have 500. Yeah, it's now further down. Let's take a AUC. So AUC scale is 0.77775, which is 78. Yeah, then you can see the different positive rates, true positive rates, false positive rates, etc. shown here. So this is the, so in the what we printed is false positive rates, true positive rates, thresholds, and then we have plot. So ROC score, false positive rates, you can see here, true positive rates, different values plotted, and its thresholds used. You can see for 0.5 threshold, 0.7 threshold, 0.6934, etc. Various thresholds used, and its different outputs, false positive rate and true positive rates, which we saw, and how it is used to plot the output here. Yeah. So we have this model output as 0.75. This is how the predictions are done. So we have come to the end of the video. So we have seen how the predictions are with the predict method and how the prediction probabilities are, and we have measured it with the curve, AUC curve, how good the model is. Yeah. So here we have addressed the following things: how the feature list looks like, how the transformed matrix looks like, how the first car review features are, how it is calculated, how the test data should be transformed before it is predicted, should a new instance of CountVectorizer be created and used for transforming the test data, and what is the difference between the predicted probabilities and predict method, and what the predicted probability gives out two columns actually, what are those, negative class and positive class, how the curve is plotted, how the area under the curve is determined, what does it mean actually, etc. Yeah. So here we come to the end of the session for classifying the text. We have seen a real example of car reviews, and you used logistic regression models and multinomial model as well in the code to test the data, to predict the model and fit the model, etc. Yeah. Thanks for listening.